It is in a valley just like this where you will find one of the many biogas-producing anaerobic biodigestion plants built by our Seco AgriPower division, which provides ready-to-go plants with power ratings which go from 250 up to 2,000 kilowatts. Thanks to their technological reliability and their high productivity rates, they present a great opportunity for farms who are looking to branch out into possible new areas of activity, to boost their finances in an ecologically sustainable way which will last as long as the plant is active. Our 40 years of experience producing machines for feedstuffs and our in-depth knowledge of the products used in this field have helped us to produce a new generation of biogas plants which offer biomass savings of up to 30% compared to conventional plants. The digester is therefore a sort of biomechanical macroorganism which reproduces the functions of the ruminant stomach in a more efficient and stable way, producing biogas which is available for use in two different forms of renewable energy: electricity and heat. Seco AgriPower's innovative and exclusive technology, which was developed by means of mechanical and biochemical processes, allows an efficient and efficacious use of the biomass entering the system. The first part of the process is carried out by the exclusive turbo refiner machine, which simultaneously microshreds the material, exponentially increasing the available surface area for bacterial attack, and actively mixes the base with other solid liquid organic complexes. Biomasses pre-treated in this way are then fed into the global energy pre-fermenter, where the mix undergoes a complete homogenization, giving the perfect mixture which is already undergoing the anaerobic digestion process. The global energy pre-fermenter is one of Seco AgriPower's principal innovations for improving the performance of the plant, as it allows the pre-digestion of the biomass by infusing it with the enzymes and bacteria which reside inside the digesters. During this phase, the biomass undergoes a real and proper biochemical enzymatic pre-digestion process. The presence of a total mixing system boosts the homogenization function of the turbo refiner, while an efficient heating system of tubing panels keeps everything inside at the optimum working temperature. This pre-treatment system kickstarts the biogasification reaction inside the digesters in only 2 to 4 hours, as compared to conventional setups where it can take from 24 to 36 hours to get going. Then the material, in the form of a melted paste, is ready to be pumped inside the digesters through a multi-directional piping system. The efficient combination of an ultra-refiner called rotor-cut and volumetric pumps managed by flow sensors transfer correct quantities of material from the pre-tank to the digester on a daily supply basis. After a sufficient holding period, the biomass moves from the main digester to the secondary digester for the final phase of the fermentation process. Inside the digester, the mixture is kept at a constant temperature and stirred by means of specially designed mixing blades. The digesters, with pressurized chambers and flow control systems for optimized biogas production, are all constructed from single-block reinforced concrete with great insulation properties, thanks to a covering which is made of a special insulating material called styrodur, and to a coated corrugated covering. The biogas produced is collected in constant pressure vessels gathered closely round each digester, made of flexible plastic sheeting which guarantees the system total impermeability and structural integrity. Our plants, which are of a standardized and modular construction, make the whole process much simpler and, as a consequence, bring about financial benefits and ease of running. Another unusual feature is the multi-digester system, which allows ease of access at the inspection points along the digestive process. After the cleaning sequence, the gas passes into the cogeneration plant, which produces electricity and heat. Part of the latter is deployed in the pre-fermenter heating system and in the digesters, while the bulk of it is used for district heating networks, biomass drying, and for the feedstuffs industry. The technology employed in the realization of the Challenger 1 cogeneration plant is exclusive to Seco. The exiting biogas is cleaned by filtering and dehumidifying, becoming perfect for combustion. The high quality of biogas produced by our plants with its high concentration of methane and very low sulfur content means low levels of maintenance are necessary for the cogeneration plant, particularly in respect of oil change periods, which are 50% less frequent. Our exclusive and patented container is the perfect and highly functional housing for all of the components, which allows maximum ease of access for all of the checking and maintenance operations. Equipped with the best combustion engines on the market, it guarantees the highest energy yields and allows for long periods between scheduled maintenance when compared to the standards of other cogeneration plants. Ease of maintenance is further enhanced by the specially placed hatches for removal of the engine for maintenance and for rotating the engine itself. The electricity produced passes to the transformer, where it changes from low to medium voltage. From here, a transfer cable allows it to be connected to the electricity grid. The heart of the management and control system is housed inside the engine room, positioned halfway between the primary and secondary digesters. Each digester is equipped with its own feed pump and can be run as an independent unit. The machine room, which is the heart of Seco AgriPower's plants, is equipped with a range of the latest generation technologies and is very practical, spacious, and easy to access. The control software, designed and developed by Seco AgriPower, allows you to optimize biogas production by monitoring the entire process. The liquid residue of biodigestion, the so-called digestate, is odorless, smooth, and comes out as a highly liquid paste. It undergoes a further refining process whereby the two final fractions, liquid and solid, are separated by centrifuging. The solid part can be used as an organic fertilizer, which can be further dried and bagged up. The liquid fraction can be used as a fertilizer spray, seeing as it is an excellent organic fertilizer. Furthermore, it contains all of the macro, meso, and micro elements which intensive cropping has taken out of the soil, and which in this way are reintroduced into it. This is the final demonstration that Seco AgriPower's anaerobic biodigestion plants represent real added value for whatever rural area they are situated in.